In this video, I'll show you how to solve word problems with two unknowns. This is question 4. The question reads, use Kirchhoff's laws to write a pair of equations for the circuit shown below and solve the equations for current 1 and current 2. Kirchhoff's law states that for loops, the sum of the voltage rises and drops around any closed loop is 0. For the nodes, the sum of the currents entering and leaving any node is 0. That being said, keep in mind the formula that voltage is equal to current times resistance. We'll start off here with the voltage for this particular part of the circuit. The voltage here is 18.2, and as we move along the circuit down here, this resistor will reduce the voltage. This drop in voltage can be represented as minus, and since we don't know the voltage here, we can represent the current as I1 times the resistance at 207. Continuing forward, it will reach this next resistor, which is represented as I1 times 126. Now keep in mind that for this particular resistor, we also have current flowing this way as well, in the opposite direction. So what this will do is it will increase the voltage. So from here we have I2 times the resistance at 207, and this is equal to 0. To model this part, the voltage starting from here is 9 volts, and it will decrease once it reaches this resistor, and we'll represent that as I2 times 207. And just like in the other part of the circuit, the current moving this way will increase the voltage. So to represent that, from I1, we will write down plus I1 207. The current continues to flow and it reaches here, and that can be represented as minus I2 156. Now once again, when it reaches a resistor, it will decrease the voltage, and this is equal to 0. Now what we have are two equations with two unknowns. Technically, this is a system of linear equations. This term and this term are alike. This term and this term are alike, so let's combine them before we start to solve for current 1 and current 2. Combining this one and this one, using our calculator, negative 207 minus 126. Combining these two, we end up with negative 333. So we have 18.2 minus 333 I1 plus 207 I2 is equal to 0. These two can be combined using our calculator. We have negative 207 minus 156, and we end up with negative 363. So 9.00 minus 363 I subscript 2 plus 207. Next, we'll rearrange both of these formulas by bringing the constants over on their own, and we're left with minus 9.00. Now you can solve this either using the addition subtraction method, substitution, elimination, but I'm going to use my calculator because it does have a function where I can solve for my two variables, mode 5, 1, and this gives us a current of 0.10. We'll leave a few decimal places more. And that's I1, and I2 is equal to 0.08668. To interpret this, this has a current of 0.1085 amps, and this has a current of 0.08668 amps. Now you may want to represent this in milliamps, and you can simply do that by multiplying both of these by 1000, but it really doesn't matter in this case. And so there you have it. That is how to solve word problems with two unknowns.